Okay, I'm Lauren with Physics 350. This is homework 2, problem number 4. So for part A, we have two charges located on the x-axis, one at negative d, one at positive d. One of them is 3q and one is negative q, and we want to find the volume charge density of the system of charges, and we want to use the Dirac delta function. So this is what it looks like. I have a picture. This is the 3q, this is the negative q located at positive and negative d. This is how we find rho. We do a summation of all the charges multiplied by the Dirac delta function with the r vectors. So if we just add them together, the first one's 3q, the second one's negative q, and the first one's located at negative d, and the second one's located at positive d. Part B. For part B, we have a spherical surface of radius r and a uniform surface charge, and we want to find an expression for the volume charge density. So for part B, again, we have rho equals some constant a, and then the Dirac delta function for the radius, because we use the Dirac delta function for parameters that are infinitely thin, and this occurs in the radial direction for a shell. So in order to find the constant a, we use the total charge is equal to the integral of rho d tau. D tau is r squared sine theta dr d theta d phi. If we integrate from 0 to pi, 0 to pi, and 0 to infinity of that, we end up getting that q is equal to 4 pi big R squared times a. And solving for a gives us q over 4 pi r squared. Q is a total charge, 4 pi r squared is the surface area of a sphere, so that's a charge per surface area, or what we're calling sigma. So therefore, rho is sigma times the Dirac delta function of the r vectors. And for part C, we have a linear charge density with that equation, and we want to talk about what the charge distribution looks like, how much total charge we have, and what the units of all this stuff is. So that's the equation. From part A, we can remember that we use the summation for this. This is what the picture is going to look like. So the first charge is q naught, and the second one is 4q naught from here. The first one's located at x equals 0 because we're not adding or subtracting anything inside the Dirac delta function to that x. And the second one is located at positive 1. The total charge is going to be this charge plus this charge, which is q naught plus 4q naught, or 5q naught. And then as far as units go, we're going to have the charge was given in coulombs, and so the charge density has to be coulombs per some length, which I'm going to call meters. So that has to be equal to this charge had better be in coulombs. The Dirac delta function gives us 1 over meters if x is in meters. The 4 has no units. The q naught has coulombs again, and then the 1 has to have units in meters, so that the x with units in meters can be the 1 can be subtracted from the x, and then the Dirac delta function will give us 1 over meters, and then we can add everything together and get coulombs per meter.